Hi everyone and welcome to a brand new video. Today we are going to be talking about the problem on the screen. So basically you are given a ordered integer list and you need to find the median. So we need to actually develop a class. In this class we instantiate the list. Here we add a number to the list and then we are going to be finding the median using this method. So first, very straightforward, let's create a list for our integers so that we can add numbers really easily. Perfect. And then what I'm going to do is I'm just going to do list.addNum. And here I'm going to say that if list.size mod 2 is equal to 1, and you need the parentheses if the thing is one line, return list.get list.size divided by 2. Because if we have an array of 2, 3, 4, so the length is 3, 3 divided by 2 is 1, and that's the middle element. And then else, we return list.get, list.get list.size divided by 2, and looking at an array, 2, 3, 4, 5, the length is 4 divided by 2, you get this element. So that means you also want to get list.size divided by 2 minus 1, and then you divide by 2. However, there are some issues with this code. First, if we run this over here, let's actually test it out and run it. So you can see here that when I run it, we get 2.0. But the thing is that when we get the median of 2 and 3, the answer is 2.5, not 2.0. And the reason that is because when we do a parenthesis like 1 plus 2 divided by 2, it will always take the first number and make that the data type of the whole thing. So we'll do is say that, oh, the first thing's an integer, so it's going to be 3 divided by 2, it's going to make an integer. So what we want to do is we want to just multiply 1.0 times, and that will just make the first thing a decimal. So now if we run it, we should get 2.5. The other issue that we get is that if we do something like 6 to 10, and I'll uncomment this, we get the median is 2. But what we want is that when you find the median, you have to first sort it. Or in this problem specifically, we want to sort this list first. But the thing is that if we do collections dot sort list every single time, that will take a lot of time. It'll make our O notation really big. So instead, all we need to do is find the right index to put this integer in. So in order to do that, we're going to create another method, and it will be called binary search. And we're going to take in a number and return the index it's supposed to go in using the binary search searching algorithm. So int left is equal to 0, int right is equal to list.size minus 1, and do while left is less than equal to right. If we're going to set int mid is equal to left plus, and this should be really familiar. If it isn't, you should become familiar with it because it is super helpful and a lot of interviews ask for binary search. So array.get mid is greater than, is actually equal to num, then we return left, mid. Else if array.get mid is less than num, then we have right is equal to mid minus 1, and else left is equal to mid plus 1. And then at the end, we're just going to return left. And whoops, I actually said are, these are dot list. So just to make sure this is working right, what we are doing is we have these two pointers and we have them on either side of the array. And then because this is sorted, we're putting this in sorted. If we have all we need to do is say that if num is less than, it's not going to be on that side of the array. So you can move the pointer. And all we need to do is find that right index for the number, and we can say int index to put it is binary search of num, and then we put index here. And the reason we're doing this is that we always put the number inside the right place to make this list always sorted, so that we don't have to run collections.sort every time just to put one number in its place. So now if we run this, it should work. And there we go. We have it's sorting to find the median. So this is the solution for the median finder question, and I hope you found it helpful. See you in the next video.